there's probably more other things I can find that are
Yeah, I've
in
done
the wheelhouse.
questions with like strings, dictionaries, heaps, arrays, linked lists. Yeah, I've
Yeah,
done
yeah, yeah.
that so far in DP.
Yeah, yeah, yeah. Gotcha, gotcha, gotcha. Yeah. Well, I think that's fine. We'll do. Okay, that's good. Do the. I think I'll do these. Okay. How's this one? This one should be pretty chill. Anyways, yeah, we're just about to get started. Let me just make sure. Is the stream running? Okay, I think that's fine. Yeah, and then wait. Let me turn off this thing. Cool, cool, cool. Okay, and then let me update the title. Now should I do that? What we'll do? What we'll do? All right, that's chill. That's chill. All right, are we ready to go? How you feeling?
Yep.
Okay, sweet. So, welcome to this week's mock interview. In case I'm not sure how familiar with the format, but these will be about an hour long. And we will be spending, we'll just go right into the problem. There's no point dilly down. We'll go right into the problem. We'll spend 45 minutes today on the problem, okay?
Hmm.
And after that, we'll have 15 minutes or so, hopefully, for any feedback slash follow ups. All right?
Sounds good.
Okay, so I'm just going to post the first, by the way, is Python your preferred language?
Yep.
All right, perfect. So feeling a bit lazy today, so I'm going to just paste the question straight. Please have a read. Let me know if you have any questions, and begin.
Okay. Yeah. Integer where cost is the cost of the ith step. You either climb 1 or 2 steps. Oh, I think I've seen this question.
That's fine. You can go for it.
Uh, okay. Yeah. Uh, is the cost of the ith step. Once you pay, you can either climb 1 or 2. You can either start. Right. Okay. Um, so, all right. Let's like just have an example first, I guess.
If you've seen
So,
this problem, because it's a mock interview, please just do it as fast as you can.
okay.
Yep.
I I think yeah, there's some like recursion going on here. Um, I forgot what the recursion was. Let me just say like let's say I had an example like this. Like let's see if I can figure out the recursion. Uh, Cost of the ith step. Okay, like let's say this is the cost of the second step. You either go here, you can either climb to here or here. Turn the minimum cost to reach the top of the floor. Um, so I think I should probably reverse the list because yeah, I guess maybe I should probably reverse the list because I'm trying to get to the end at 5. Like I'm trying to get to this part and maybe then I want to do, or no, how about this? How about I do like minimum to get to the kth step? So I keep like some function that's like minimum to get to the kth step. And then I guess what I'm trying to output is like f of n. Okay, in this case, uh, f of 0 is, well, I guess I'm already at the 0th step. F, once you can either start with index 0 or the step with index 1. Okay, I guess both f of 1 and f of 0 are 0 then. Um, sure. I guess in this case, yeah, I guess in this case, like if I had the array just be 3, 4, it would be, yeah, I start at index 0 or 1, so I guess it's 0 steps there. But now let's say I had this as well. Now for f2, which is the minimum cost to get to index 2, yeah, okay, so it's then like min of f0 and f 1, I believe, because I can either climb 1 or 2. No, this is not right. Yeah, because then this would be 0. So, I guess we have to keep these as dummy. I guess F0 and F. Okay, I guess I'll do something like, oh, if the length is 0, if the length is less than 2, I'm just going to say it takes 0 steps. But otherwise, I'm going to set a dummy like F0 and F1 to be 3 and 4 in this case. And then this would be the min actually. Yeah, because in this case, that would be 3, because I would go from the 0th step, I would pay the cost to go 2 steps. And then is the recursion just, yeah, okay, I guess then in general, the recursion is min of fn minus 1, oops, f of n minus 1 and f of n minus 2. Yeah, because this is the minimum to get to here, and then I can take 2 steps. This is the minimum to get to n minus 1, and then I can take 1 step. And the minimum of the 2 is the best thing to do. Okay, so I think I can begin, I guess.
Okay, so hold on. So for your example, what's the answer? Just so I understand here.
To get to the end, oh, okay, I haven't worked that out. I guess I would then do F3. That would be min of F0, F2 and F1. Since F2 is 3, this would be 3, and this would also be 3. Oh, no. Wait a second. Wait a second. Min of F. Okay, it's not this. Sorry, it's not F2. I think it's cost. No. Wait a second. I think it's like, yeah, no, sorry. This is not the right recursion. Let's think about this again. In this case, yeah, this is right. But like F3 would be the min of. So I'm trying to get to the 3rd step. Okay, I think it would then be actually F2 plus cost 2, and then F1 plus cost 1. Yeah, sorry, I messed that up. Yeah. In this case, then, like, to get to let's say, like, this was the array, to get to the end, since you can, yeah, okay, to get to the end, I guess F2 plus cost 2 is 8, F1 plus cost 1 is also 8, so I guess it would be 8 anyways. So
yeah, I guess that example doesn't really differentiate, but
yeah,
that's fine.
yeah, but in this case, yeah, this is the recursion. In general, it's fn minus 1 plus cost n minus 1 and fn minus 2 plus cost n minus 2. Because you actually have to pay the cost of using the step. Okay.
Yeah, to get
I
to the
think
current,
that's
like
correct.
this is to get to the current in,
I think to get to
right?
the nth.
Okay, and what will your in be? Like, is it?
In,
Yeah.
in the final answer, yeah, the n would just be the last index of the list. So like length list minus 1.
Okay.
Yeah. So I'll begin coding that. I guess I'll call it min cost, sure. And we're probably going to be given cost array. Yeah. And what I would then do is I first have to check, yeah, if the length of the cost array is less than 2, then I just return 0 because yeah. And this is what I explained before. If, okay, otherwise, so I have at least 2 elements, at least, sorry, less than or equal to 2. Yeah, otherwise I have at least greater than 2 elements. I would then set, I guess I would have to do something like this. 0, 4, I in range, length cost. Oops. Is that the Pythonic way to do it, or is it like 0 times? Is it? Okay, I think it's that. Okay.
What are you trying to do?
So I'm making my DP array. First, I'm going to initialize everything to be 0. Or maybe I should say inf actually. Or yeah, no, that might be a problem. Let me just like do import math and make it math.im, I guess. Because I'll be taking minimums and I don't want there to be a problem. I would then set dp0 and dp1 to be like cost 0, cost 1. So this is my initializations here. And then, okay. And then I would go for, let's say, I in range. I would start from the second element, and I would then go up to, I would start from the second index, and then I would go up to, okay, let's just call this like, let's just make this a bit, I don't want to keep retyping this if it comes again. Let's just say, yeah, I would go from the second index onwards up until the end and fill in my 1D DP. So I would then say, okay, DP I is the min of DP I minus 1 plus cost I minus 1 and DP I minus 2 plus cost I minus 2. Let's see. So in the case of like 2, that's the first one. You get dp1 plus cost 1, dp0 plus cost 0. This is not right. This is not right, no. This is right when it's not 2. Okay, maybe I should start from 3 and actually then set dp2 to be min of cost 0 and cost 1. And let's see now. Well, okay, I guess I should then have another check. If size is actually equal to 3, I just return dp2. So now, yeah, if the size was 2 or less, it was 0. If it was 3, there's like a different kind of recursion. I return that. And now I know that I have more than 3 elements. I can do my actual general form of the recursion, which is min, like it's this part basically. So the recursion for the second part is the min of the last 2, but in general, the recursion for the nth is the min of the last 2 plus their costs as well. So okay, once you do that.
Wait, so why do you need to start at 3?
Oh yeah, that would start at index 2. Yes.
Okay.
No, sorry. Wait. Wait a second. DP0, DP1. DP2 would be the third element. Okay, yeah, and if the size was 3, I return DP2. Yeah, I would have to start at the fourth element because my DP would be, my DP array is like, this is, min to reach, I mean, this is 0, 0, and then the min to reach 2, and then it's the min to reach 3. And so this one would be index 3. So I have to start from here. And yeah, I have to start from index 3, I think. Is that
That's
is
fine.
that right?
That's fine.
Okay, so I start from index 3 then. In this case, it is actually this plus the cost and this plus the cost. So I think this is fine then. And I think then I would just, once I filled in the table, because this goes up to size minus 1, I would just return dp size minus 1. Yeah. I think I would just do that.
Okay.
I think, yeah. And I guess, do we want to check this maybe with this example?
No, we don't need to check that. What I will say is, what if now, instead of the goal being that you get to the last element, the goal is that you need to get past the last element. So
Past
you
the
need to,
last.
yeah, exactly. So if this is your input, you need to actually, well, let's just, I mean, this example is not super fantastic. Let me copy paste an example here.
Yeah.
Let's save an example here. Um, let's say you have this example, and our goal isn't like to get 220. Our goal is to get off, like past all of these stairs,
Oh, I see. Yeah,
right?
like to get to
So
basically the next one.
yes,
Okay.
exactly. Get over here. So in this case, the answer would be 15, right? Because you choose to start over
Yeah,
here, you would incur the cost of 15 to jump to, and then you would exit the list.
I see. I see.
Does your answer
Um,
change to accommodate this?
let's see. So, clearly the base case has changed. Um, yeah, clearly the base case has changed because, um, yeah, because I mean, if I have a two, yeah, in the case of having a two array element, I would have to change this and make it like return the min of cost 0 and cost 1 instead of just 0. What about the third case? Sorry, yeah, in the case of having 3 elements, in the case of having 3 elements, I think, let's see. Okay, I think it just, instead of becoming dp2, becomes like min of dp2 plus cost 2 and dp1 plus cost 1 for the same reason. Again, I get there and then I have to take 1 or 2 steps, which is paying the cost. So this changes as well. And the recursion, I think I should keep it the same because I think I can still say, hey, dpi is the cost, the min cost to reach I, but then the final answer I think should, instead of this, be return dp size -1 plus cost plus the last cost. Oh, sorry, the min of that with dp size -2 plus the second last cost. So yeah, because again, if I'm, let's just say, yeah, these are the last two, I can get to the last and then I have to pay the cost to move past it, or I can get to the second last and pay the cost to move 2 steps. So I think this is how it would change.
Okay. Um, I can't help but notice that this is the same as this,
True. Yeah.
right?
So
So in
this,
this case, you wouldn't need to have like a special case here. Is that right?
yeah, yeah, this special
Okay.
case would get absorbed and this index would start at 2 then. Yeah.
Okay. All right. Cool. So there's so I have a follow up for this question. I don't necessarily want us to um, like do this necessarily, but I wanted to you know just to see how you might think about this.
Mhm.
So I'm gonna paste this question again. I'm gonna have you have a read, and we don't need to modify any of the code we currently have. So we're gonna just write anything new over down here. So the main goal here is just to check your understanding, see how you would approach this. But again, we won't be actually implementing this problem here.
Okay. Since you're given a non-integer k, non-negative integer k, there's a staircase with infinite stairs. Lowest stair number 0. Okay. There's a jump with an initial value of 0. Stair 1. So reach stair k using any number of operations. She's on stair I. Operation she can go down. Okay. Go up. And oh, this is like a variable. Okay. Okay. The total number of ways Alice can reach stair k. Okay, so in this case, like if you can reach stair k and also like sort of keep going back to reach somewhere below and then reach stair k again,
Mm-hmm.
do you just say that there's infinite ways then? Like
Um,
if you can keep going in a cycle?
can you clarify what you mean by go in a cycle in this case? Oh, I see. Like if you just
Uh,
do quote unquote like useless steps, but just revisit the same two stairs over and over again.
yeah,
Um,
yeah. Is that possible? Oh, I
that's
guess not, because jump.
yeah. That well, I don't think that should be possible. And if it was, I
Yeah,
don't like we that wouldn't be any different. I'll probably do this example. It's good to just look through.
yeah,
And what I want to get out of this is I want to see, do you have any initial intuition about this problem? Again, we're not
yeah,
trying to, we're not going to solve it here, but I want to see, do you have any thoughts about it? Do you have any ideas for an approach?
yeah.
Um,
So
Please have a read. Yeah.
I'm I'm seeing, yeah, this is the return the total number of ways. Again, this is some function f of k, and essentially I think I'm going to have to come up with some recursion again.
Okay.
Um, my initial thought is like this is basically the two things I could do. Like, you know, these are my two things, and like I guess they'll correspond to two terms. Oh, okay, weird indentation is weird, but yeah, it corresponds to two things I could do, and so like I'm expecting two terms maybe. So I
Okay.
would say, okay, um, um, let's see, okay, go down to stair I minus one. What does this operation actually mean? Um, what does this operation correspond to? Um, okay, but let's say I'm not at stair zero. Okay, I'm at some stair I. Let's say if I'm at stair I, or yeah, if I'm at stair I, now f of k, there's going to be a term added to f of k, which is of the form, f of I, number of ways to get to I, and then um, I could go down, and I would then have f of I minus one. Uh, go down, and then I would have f5. Okay, but jump also matters. Okay, wait. So maybe this is actually f of k jump. So it's like a 2D. It's like it depends on two variables. And like, let's say if I was on fi and my jump was some jump j, if I'm on step I, so like it takes me fi j to get there, um, then I can go down. My jump doesn't change. I become fi minus 1j. And that's a thing, okay?
Okay. So it sounds like you're looking for a 2D recurrence.
I'm looking for a 2D
Okay.
recurrence that depends on the step I want to get to and the jump that I have. Uh, my jump is initially 0, so my answer would be something like, yeah, f of k 0. But yeah, I think it would be some long recursion, which is like a
Okay.
sum of many terms. Let me
Yeah.
actually look through the example.
There's no deal. I just want to clarify this part. So, it'll be a function of where you want to get to, your current jump.
Yeah.
Okay. Is there like any like third variable or anything, or you're like considering putting in as well, or is like these the main two?
Let's see. I think, well, it might come up, but for now, I think I would want to keep it 2 and try to come
Yeah.
up with the recurrence and see what matters. Yeah.
Yeah. Okay, that's fine.
So,
We'll move on from the problem. I just wanted to hear your initial thoughts there. That's fine. Okay, so we're gonna
oh, so
change
we're
gears a
not going to
bit.
do this one?
What's that?
We're not going to do this problem?
No, no, no.
Oh,
This problem is a difficult one. I want to just ask it to you just to kind of get you feedback afterwards. So
yeah.
this is where the mock interview is gonna be different, right? Where I'm gonna ask you a question. We are gonna finish this. In a real interview, they might just sit here and have you finish it. But again, the goal here is to give you some feedback, so we won't sit here for that.
Right.
Unless you really want to do the problem, which I don't recommend. But if you really want to do it, I
Yeah,
will
no,
help
I'm
you with
okay.
that. Okay.
I'm
All right.
okay.
So moving on to a more approachable problem. This time I will actually dictate the problem. Okay. So please start at the bottom here, and take notes going downwards. Okay?
Okay.
So this problem, I'm not sure I heard this one as well. It's called group anagrams.
Okay.
In this problem, your input to a function is going to be a list of strings. Okay? And then, and the strings, some of them might be anagrams of each other. Or some of them, or maybe none of them are anagrams. You don't know. Okay? And the output is going to be a list of string. Okay? Where each list of string are all anagrams of each other. So you want to group all the anagrams into one list, and you have one list per, unique anagram.
Okay. So I want to have. Oh, okay. Wait. So do you mean like I get some list of strings, like I don't know, I get some strings like S1,
You can
S2,
use this one.
Oh, sorry. Okay, yeah. I get this, and then I should output like, oh, eat is with, T, and I guess 8 as well. That's my first group, and then my second group is like, I guess nat, and then the third group is like bat, and that's how I want to make it, or something like that. Yeah.
Yeah, you're missing one over
And
here. I think you're missing tan
yeah,
here, but
and,
yeah,
yeah.
same idea. Yes, correct.
Okay. 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 So I just get a list of strings, and I try to group the anagrams. Okay. Okay. How would I do this? Well. Okay. Okay, I know you can check if something is an anagram by like, okay, maybe I just need, okay, firstly I would need to check if something is an anagram. Is there a nice way to do that? Oh, yeah. There's the, yeah, you can do like, what is it called? From collections import counter. This is like a built-in function that like, basically counter S gives you a dictionary of like, the character and how many times it shows up. So I would basically check, okay, if something is an anagram, I just need to check if counter S1 equals counter S2. So I can check if something is an anagram, and I think that does it in linear time. So I would, okay, I have a way to check if two strings are an anagram. I need that. Now, what do I do then? Do I just start iterating through the array? I start iterating through the array. If no anagram, okay. So there's like a result list that I would start with. Let me do it here. There's like a result list that I would start with. If there's no anagram in this, like, I guess I would check the first element in the result list. So like, I would probably do something like, oh, for group in res, I check like, check group 0 with S, like, are they anagrams? If they are, okay, I guess I'd probably need to keep track of the index as well, which I can do. If they are, then I would just push it to that index in res. If not, then I just append a list of that to res. So my initial strategy is basically have this result array, then iterate through strings. If I see a string that's an anagram of the first, let's say, element in this group list, then that means it's part of that anagram group. I push it to that same part. If it's not a part of any anagram groups, like let's say in the first case, then I make an empty list, then I make a list with it in it. That's what I would do. Although, okay, I guess I'll code this one up, but I feel like this is not the optimal solution, but I'll just code this one up. Is that okay?
Yeah, that's fine.
Okay, yeah, I'll call this group anagrams. and I get a list of strings. Let me just call it, I don't know, words. What I would then do is, okay, so I would first have res be actually, this would do the weird thing where like in the first case it would make like this. So maybe this is not the best way to go. Maybe, okay, I need to like think of how to initialize this. All right, okay, I guess I would just initialize this by the first word. Sure, I would initialize it with the first word, word 0. So in our example, this would like initially be, oh, I guess, sorry, there's also going to be the word list is going to be non-empty, right?
Yeah, that's fine to assume. Yeah.
Okay, and yeah, these are all strings that are alphabets, or can they be numbers too?
They can be any ASCII characters.
Any ASCII character, okay. Okay, that makes it a bit, okay, that's, okay, fine. So in this case, yeah, this would start off like this, which is fine, that's what I want. And then I would go for group in, oh, sorry, I guess for word in words. I now have a nested loop for group in res. I check if counter word equals counter group 0, which is fine. That's not going to error because there's always at least one element. If counter, oh, sorry, I was supposed to do the index as well. So index group in enumerate res. If basically my word is n, can there be repeat words or no?
Oh, yeah, there could be, yeah.
And what do we do in that case? Do we not include it or?
Well, you should still include them because they're anagrams after all.
Right, so like if this had tan again here, I would put tan 2 times.
Yeah, exactly.
Okay, that's fine, yeah. So in this case, yeah, this is fine. I would then just say, okay, if the words are indeed anagrams, then you go in this, so yeah, you're in the index, you're in the index part of the result, and you would then append word. And if not, so the loop happened, the loop happened, and then nothing happened. Wait a second. Do I need to keep like a flag or something of, should I append it or not, or can I just do it at the end of the loop? Okay, maybe I should just do this then. I should just break here. If I found thing to append into, I break, and that would break me out of this loop. And then I would, so now I went out of the loop, none of the if. Okay, you know what, no, let's just do it, let's just do this in a bit more of a complicated way, I guess. Let's just do it, elif index is, yeah, I guess I should do this in a bit of a weirder way. Elif index is length of res -1 and let's say this happens. This is a bit of a weirder way to do it. This means that I went through my loop, I went through res, none of the words were the anagrams of what I had seen so far. I need to now append. I need to now actually append to res an array of word. This is my new group. Yeah, don't have a very slick way of doing this, but okay. I think then that would be it. I would return res, and that would be it.
Okay. Okay. Can we go through the time and space complexity of this, please?
Yeah, so the fact there's a nested loop, uh, pretty much, yeah, you would have to compare each word with like the group representative all over again. And in the worst case scenario, this would be O of n squared because, yeah, let's say like you have n over 2 different words, and now you're comparing like the n over 2 plus 1th word, but it's not an anagram of any of the other. So like, let's say you had an array of n distinct words, you can see that the last half has to do like the last n over 2 have to compare n over 2 times each time. And so that's n squared basically. So in the worst case, this is O of n squared complexity. I guess, yeah, it could be O of n in like good cases, but worst case complexity for time is O of n squared. Space, I think just O of n, extra space. Yeah.
Okay, and what is n?
N is the number of strings in words. So yeah, the size of this list.
Okay. Well, the size of the list also depends on how many characters are in a string, right?
Right. That's true as well. Yeah.
So how
Oh,
would you capture that?
okay. I mean, we can then do like we can say that okay, C is total number of characters, or we can say like each string is like approximately k characters. So there's n, and then can we say that then each string is approximately k characters, or do you want to say
I mean,
C is
you
the
can say
total
whatever you
number?
want, but like, what are you gonna do with? Let's say that sure they're on average k characters, but what does that tell you?
Okay, if they're on average k characters, then I think this counter check is O of k, which actually means this is O of n squared k time complexity, because you have to do the O of k check n squared times. So yeah, that's yeah.
Okay,
Time complexity would be O of n squared k.
and how about space?
Space would then be O of nk, yeah. Same thing again,
Okay,
the input space, yeah.
okay,
But this is not optimal for sure.
okay, cool. Um, we have a bit of time left, so I feel like we can we can probably improve this a little bit.
Yeah, now's the hard part, yeah.
Yeah, no, I think your idea overall makes sense, but it's probably unnecessary to. I think there's two parts we can probably improve. The first part being doing this check every time, and then the second part being whatever's going on over here.
Yeah.
Maybe you can start with this one first. I think this one might be a bit easier to improve. Right. So your
Um,
goal here was to So what was your goal here essentially?
if I did not find any anagram, so I went through my representative of the elements in like res, and I didn't find any anagram yet. So it's a new group. I need to make the new group to res. I need to append the new group to res.
Okay.
So that would happen if I looped through res, didn't find my anagram. So that means I need to append it. But is there a slicker way to do that? I guess. Um,
Well,
maybe.
yeah. I mean, so you mentioned a couple methods before, but let's back up a bit. So the reason you're doing a like quote unquote check, and I guess you could say check in the first place, is because you don't know what the key you don't know what this value really is, right?
Yeah.
You need to compare the strings every time with the first string of a group,
Yeah.
and that's fine. There's nothing wrong with that. But if we're always comparing an item, like in this case our current item, in some way to a group, we should probably be using a dictionary structure, right? Where the key is a representative of
Yeah.
all the elements that belong to that key.
Right. Yeah. And this does give you the represent. This does give you the
Yes.
yeah.
So you can almost think of that as being the key. Could you refactor this to take advantage of this fact?
Um. Like okay. Like counter of like eat, right? Would give you like it would give you a dictionary of like this and like your question is, can I make this into a key itself?
Mm-hmm.
Um. I don't think dictionaries can be keys, right?
No, they actually cannot.
Okay, yeah, yeah, okay, because they're mutable. Okay, but so okay,
Is your
uh,
only reservation that there is your only reservation that they can't be a key? Like if it could be a key, would you use it as a key?
yeah, if it was like like yeah, I mean then yeah, because
Okay. Do you know how to
yeah,
turn a counter into a key?
well, it depends. Like, what are you said all ASCII characters?
Yeah, all ASCII characters.
Okay, so I guess then like okay, I don't remember how many uh numbers there are in ASCII, but like let's say I don't know, is it like 120 or something or
It's 128.
128? Okay, so like you could then have a tuple of 128 characters. I don't know which one corresponds to one, but like, you know,
Okay.
this, like, let's say the first character is A, let's say the
Okay.
second character is B, then like you can have a tuple instead of like, so in this case, this tuple would be like this because B is 0, C is 0, D is 0, E is 1, and then like it keeps going 0, 0, and then like, you can make it a
Yeah.
counter like this basically.
Gotcha. All right.
So,
Let's assume that counter can be a key and proceed.
okay, so if I could make this a key, if I could make this a key, what's the oh, then I just look up. I can do an okay, I can do like a fast lookup for a key. Okay, right. Okay, yeah, I can do wait a second. What am I supposed to do? Okay, I feel like okay, my raw idea is that I would also have like a dictionary of keys basically of like the groups I guess sure group keys or whatever would be like it'd be my keys and I basically every time I every time I look up a new word I check is the word like is so there's some function that transforms word to key like this like let's say I could do this then every time I see okay does the key I get does it exist in the dictionary and if it does like what is the index or something of it because then that corresponds to the group that I'm in. And this is like an O1 check basically. Okay, so if in theory I can do this function, then I say, okay, for word, like as I'm going, I don't need to do this. I need to check is the key associated to that word in my group keys dictionary. If it isn't, then of course I have to make my own new group and I have to append the key corresponding to it. But if it is, then the key's value should be the index in group, like in res corresponding to that key. And then I say, okay, then in res, in that index, append my actual word. Does that make sense?
Oh, yep, that does.
And
Um,
that would make this part of one basically.
yeah. So could you pseudocode that? So what would this be instead?
Um, okay, so well, I guess I would have like some function. Okay, let me say I had a function that like said convert key. So like let's say I had a like I would say then like key. Uh, you know, okay, uh, let me do this in comments again. Let me say I had then, key would be convert key. This is some function that does what I wanted it to do. Then I would then check, okay, if also I would have a dictionary initially of like, you know, I guess, yeah, group keys. Group keys is initially a dictionary, and I guess I initialize it with, I initialize it with like convert, sorry, convert key for the first word, like word 0, and then the value, which is 0 because it's first one. And then I say if key in group keys, okay, if key is in group keys, then I just do res group keys key. So that's because this corresponds to the index in res. I would do this dot append actual word. Else I would do res dot I would do res dot append my word, and then also fix up the dictionary, because now I would have to say what would it be? Group keys dot, well, I can't just put in the key because it doesn't exist. Maybe I would make this like a default dict. Okay, like, you can do this as well. Or what is it? Is it, yeah, or no? Can I do this? I forgot if I can do this. Can I do this? Can I just do this?
Yes.
Can I just do, yeah, okay, I think I can just do this then. So, yeah, I think I can just do this then. Yeah, okay,
Okay.
I think that would just be it then. Yeah.
And what would the time and space be in this case?
So in this case, this key checkup is of 1. And so now, okay, well, convert key, this has some complexity as well, I guess. This has, I guess this is also of k. The convert key function is of k. And, well, unless is there like a really super fast way to do it? Is it O of 1 actually? I don't know, but like this function to get the word to this key, that has some like I guess naively I would say O of k, unless there's like some clever way to do it with like bits or something, I don't know. But if not, I would say this is O of k. Then the checkup itself is O of 1, and this checkup is happening for each word. This checkup is happening for each word. Huh. So is it just O of n plus O of, like O of n plus k then? Because the actual word complexity is like you just do it for n words, and for each word it's an O of 1 thing. Oh no, but then for each word you also do this thing. Yeah, sorry. So it's O of n plus O of n. Oh, okay, yeah. So it's basically O of nk. Yeah, that seems more right.
Okay.
And
Does the
space
space
complexity
change?
would be the same.
Okay. All right. Cool. I'll end the mock here. We'll go into the after show. Um, Usually for these, I start by asking, how do you feel about the interview? How do you feel about the format today?
Okay, I think on the problem that I didn't see, I have the right idea on how to optimize it. So I think I did okay-ish there, but yeah, I don't know how to actually write this function. So I don't know, that might be a bad thing. But I would say I did like borderline good.
Okay. How do you feel about the first problem?
Yeah, I think I had already like I remember I did a different question. I did the Fibonacci one, which was like it's just like, I mean, it's a similar idea, but I've done something that's like similar, where it's like, oh, what's the cost? And it's like, oh, it's the nth Fibonacci number, and so it's DP. But I think, yeah, I think I did something like this before, so I knew pretty much, and then I figured out the recursion on the spot. So I think that was good as well. But yeah, I guess you don't always get lucky like that.
Yeah. Okay. And how would you rate how correct your first or and second question was?
My first, I think my first one is right. Yeah, I would say this is fully correct. So
Okay.
a 10.
Yeah, and in your
And
second one, how correct do you think your group anagrams is? Your original version, obviously. The current one is pseudocode.
well, I think yeah, it's inefficient. My original one was inefficient as well, and also like I do checks again. Like there's something to do with like break and like there's a more slick way to do it. So I would say like I don't know, 8 out of 10 for presentation because the code was not written too well, but
Okay, but
I
you
think the
believe it was
logic is
correct.
correct. Yeah.
Okay. Um, all right, let's get to the feedback then. So, you know, there's a couple things to kind of point out here. I could broadly break this down to either the technical skills and non-technical skills, right? So just kind of kick us off. I think the technical part today, yeah, there's definitely some skill showcase here. I think you're right in that the first question you've seen a version before. The Fibonacci question is much easier than this one. This one has a more difficult recurrence relation, relation on top of that one. It's not much more difficult. It's still quite easy, but you're right in that there was a very similar problem, and having seen a similar one helps you on on a related question, right?
Yeah.
So technical skills there, but I think to start with the non-technical stuff, a really big thing here is you know how to plan to do questions, right? So this is independent of things like actually solving the problem, knowing the approach, etc. The important thing here, and I think you got this part pretty good, is start with the example, start with something simple, right? Work through that and work through it fully. Work through the example fully. Don't like back out halfway, and make sure when you're working out the example, you're highlighting what algorithm you'll be doing, right? And this is something you actually did quite well on the on both problems actually. But for the first one, you didn't actually finish the example, which is questionable. And the second one, you did finish the example, but you didn't outline your algorithm. And but each of these is like not that big of a deal, but they add up to be a bigger deal because this is a strategy issue, right? The strategy issue at play here is if you don't finish the example, you don't know if you are correct. And
Correct. Yeah.
if you finish the example but you don't outline the algorithm you're going to do, then you don't know if you're going to be efficient, right? So spending the time to actually vocalize that is going to be really helpful for both you and the interviewer, right? The interviewer is it helpful for the interviewer because they can step in if they so choose and tell you that that's not going to be efficient enough or that they would like you to pursue a different approach, right? So
Right.
strategy wise, that's important to be able to have people come in and point out when things aren't quite right. So that's what I'll say on that front. Um, Now, you had another part here that I want to talk about that was also non-technical. I guess it's a little bit technical, but not fully technical. This is more about this is more about timing and spacing. So one thing is that basically you'll know the timing of the interview before starting any problem. You'll know what the agenda will be roughly, and so you do need to pace out the time a bit more carefully. In this case, it was a mock interview, so I chose to go overtime. But most of the time, you will be cut off pretty hard at some point, or they will not. Or if they don't cut you off hard, they will they're not allowed to evaluate things past a certain time. So be aware that part of the interview is time management, and you need to mostly be in charge of that, at least to look out for yourself.
Okay.
All right. So any questions about that so far? Otherwise, we'll move to the technical parts.
Yeah. I guess was I clear in explaining my algorithms?
I would say it's hit or miss. You were pretty clear with the recurrence relationship at the start. Although the first one you explained was wrong, and the second one you explained the algorithm like your approach pretty well, but there were a lot of things you were glazing over, like for example how you would use the counter explicitly,
You know.
which is like not inherently a problem, but it is a thing where it's like, um, it's a thing where it is like, hey, if you said it earlier, you might have caught some inefficiency. Like as a very specific example, when you originally implemented it and you had this counter, um,
Yeah.
if you do it this way, you cannot say it's O of k. You need to say you need to use a different variable for that, because you're using big O notation, and big O is not the average performance; it's the worst case performance. So this will always
Right.
be as slow as the longest as long as word, right? So
Right.
so that's
Yeah.
a case where if you're not if like you're going through the emotions, but if you're not precise enough, you don't get the value out of it. If that makes sense.
Yeah. Makes sense. Yeah. Yeah.
Okay, cool. So all right, technical parts. The first okay, this is sort of technical and non-technical. Again, one of the things about the first problem that bit you at the end, which is that you didn't finish the example. The reason
Yeah.
the reason that's important is because and this is pointed out in the chat as well. This is actually not correct in that, and this is not defined in the problem as well, by the way, which is actually why you need to clarify and ask, and maybe in this case finish the example, which is that the problem actually requires you to get past the array. So you need to get past the last step. So you can't just get to the last step, which is what your original DP recurrence was, right? Like you have to get past the last step.
Oh, like the top of the floor. Okay.
Yes,
Yeah.
top
Yeah.
of the floor, which
I
means you pass all
assume.
the stairs. Right, but here's the thing: you don't need to assume that because you can just do the example and just say, "Hey, is this correct?" Right. So
Right. Yeah.
this is a case where like that would have helped you. Now, I didn't evaluate you on that part. I mean, you still were able to figure it out with that modification, so it's not like a big deal. But this is one of those cases where the interviewer will be very confused about why you're doing things a certain way because to the interviewer's perspective, it takes you maybe like 5 more seconds to finish the example, and you chose not to. Right, so that's just a case of like that's not really a technical thing, but it's like a prioritization issue.
Yeah.
First problem went well. Nothing really too much to add here, except the fact that having the size 3 base case is completely unnecessary for either case. This was quite. I wouldn't say like this part was honestly a bit puzzling, because you actually correctly did start with 2, and then you thought of something in your head and you said, "Oh, we can't do that. We need to have a base case here." I'm not really sure why that happened, but this is unnecessary. You can go figure that out on your own time. Um, and the follow up, in the quote unquote follow up in this case, it's the original problem where we had to get past the last step. In that case, when I prompted you, you did correctly deduce that in that case you do not need a special case here because these recurrence relationships are the same. But this recurrence relationship was the same even without the extension. So in that case, a good interviewee would have been able to call out, oh, actually, we do not need a size 3 base case for the previous example as well. So that's a bit of a detail there that you missed. Didn't have time and space on that one. That's pretty straightforward. I will briefly touch on this follow-up, by the way. So the reason I asked this follow-up is because this is a math problem. This is a math problem. It is not one which is optimally solved by recurrence relationships. You can do it via recurrence relationships. You do need more variables, though. It's going to be a 3DDP if you want to do it in a pure recurrence
Well,
map.
the next one.
For the follow-up, which we didn't pursue.
Right. Okay.
It is possible to solve it with recurrence, but that is not optimal. Now, this is not a problem which you will be asked, but the reason I'm asking this is because I want to get a signal on how well you can dissect the problem. By the way, this is a very common bait where they'll give you a follow-up that seems similar in style, but the approach might be completely different. So be aware of that, in that, yes, you can often reuse your previous approach, but that might not be the best way to do it. And so you should always start by, thinking at a high level, seeing is there something else that we can do to approach this problem, and not just dive straight in with your existing approach. So that's something I want to call out. If you're going for the roles that you have indicated to me, they will care a lot more about things like mathematical performance. So this problem would have been better modeled as a math problem, essentially. It's also on Leetcode. You can go find it after. But I also wouldn't necessarily recommend solving it. It is a more difficult problem.
Yeah.
All right. And then for the group anagrams, this you got, the algorithm you got basically right. There's nothing to comment on there. The main issue here was the Python scale seemed to be a bit lacking. There were a lot of things you were stuck on, which you frankly cannot be stuck on, implementation-wise, right? Like, it's one thing to get stuck on the idea, but when you have an idea, you cannot be stuck on implementation for problems like Leetcode, right? So I'm not sure what was going on there. It might have been just, maybe you're just new to Python, in which case more practice would help, or you maybe do Python, but you don't use that many collections, right? So I guess you know about collection default dict, so you're decent on that front. But whatever the case is,
it's only because of Leetcode, yeah.
Yeah, but like whatever the case is, like you need to sharpen that up a bit. getting stuck on doing stuff like this is not an instant fail, but it is very suspicious. Also because, by the way, this Python will run, but it will not run correctly because you are modifying the array as you're appending as you're mutating it, right? So you're iterating it and you're also mutating it. So that is not ideal.
Right. Yeah.
Otherwise, yeah, I mean, you got the approach. You know what's going on. I would definitely go brush up on how to use dictionaries, how to use the default dict. Default dict, by the way, here is the right approach. But I think the way you were using this dictionary doesn't make too much sense. In other words, your value is always the index,
Yeah.
quote unquote. And if your value is always an index, that's the same thing as a list, right? Like there's no point in having a value here, right? The point of having the dictionary here is to map a key to the list of words that are anagrams. This is the point. Because once you have this as your value, you can simply get your key from any given word and directly add it to this list that corresponds to the value of that key. Right? This is a pattern that people would expect. And I think, I'm not sure if you thought, I've forgotten in this mock, if I gave you the idea of the dictionary or not, or maybe you thought of it yourself and forgot. But
You
if this was
said that.
okay,
Yeah.
okay. If this was given as a hint from the interviewer, then you must use this version. Like this is a version which you have to have used. So this is one of those cases where there is basically one very obvious optimal solution, and you have to latch on that that hint is given. But last thing I'll close with is you are absolutely right in that the counter cannot directly be used as a key. So that is actually really good that you called that out yourself. There are different. So as another Python skill thing, I would recommend you go and check how to make a counter or a dictionary in general, patchable, or how you can make these things a key. In most interviews, they will. I'm not sure they would expect you to know that, but if you're going for a role which requires Python as not just a Leetcode tool, but actually on the job, these kind of skills are mandatory. You can't be missing that kind of stuff, right? So that's just a bit of a tip for you there. A couple of things to polish up on the Python side. Any questions?
Yeah. No. Yeah, that was good feedback.
All right, then that's all. Thanks for your time.
Yeah. How do I send in the resume for the resume review, by the way?
So the way you send the resume is via the Google form. So I'm gonna just start that up now. So I'll pin I'll send you the link as well on Discord since you're here in the call. And we usually don't do this in the call, but I don't mind doing it in the call. So this would be my form. Let's see. Yes, so this is this one. Let me pin it on the stream. Yes, that's right. Yeah, so you can submit it here. I usually do these on stream, which is why I have them submitted via form. Yeah. Let's see, and then let me go to the other server. What is this? What else is it all about? Hold on, where's my link? All right, did you submit yet? Let me take a look.
still writing something. Yeah.
All right, cool. Close these guys.
Yeah, I submitted. Yeah, I submitted my
Okay.
resume.
Cool. All right. So let me have a look. That's just downloading it right now. Yeah. All right. Looks fine. Okay. So going for machine learning research intern, applied machine learning engineering. Okay. You have research experience. Okay.
Yeah.
Okay. Cool. And going for summer 26.
Yeah.
All right. Let's take a look so far what you have. Right now, okay. Right now you're doing the masters, like you said. You
Yeah.
have a Bachelor of Science Mathematics. Okay. And you did some CS in your degree.
Yeah.
I see. Okay. Okay, did Putnam. Haven't heard of the other one. Recently worked at a robotics lab. This is okay. 3 months. Is that three? Was that 3 or 4 months?
3.
Okay. Okay. So you have So it looks like you have actually quite a bit of experience in research.
Yeah.
So products are pretty recent. In descending. Okay, I see. The dates are backwards, right? Like, is the Higgs one much more relevant? Is that where we're putting it first?
Yeah, it looks cooler.
Okay, that's fine. All right, and then some stuff over here. No SciPy?
No, I don't really use it.
Okay. Okay, interesting. All right. Okay, so overall experience looks pretty solid. I like what's going over here. Robotics lab makes sense. I think this one's. I mean, this is the most recent experience, but I think it's probably also your best one. 3 months, quite a bit of output here. Did you do any like more formal research, like papers or anything here?
Yeah, I'm writing up the paper now.
Okay, cool.
Yeah. Well, I haven't, gotten it out.
Okay, is that in any of the points? I'm not seeing it.
Yeah, I, I don't know. Do I say writing paper or?
Yeah, if you're working on some like a paper, then you should. And then when it's out, or preprint or something, you should be linking it on like archive or something.
I see. Okay.
Yeah, because right now, because it's a thing where like, okay, I see a lot of research adjacent or direct research stuff, but there's no paper. So if you have a paper, that's definitely good to put on, even if it's work in progress.
Okay.
So that's the first thing I'll say there. Blah 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 blah. Okay, that's pretty good. Okay, let's look at this research institute. I see. So this is wait, this one you're talking about, the Math Research Institute one?
Yeah, this one I do have a paper. I didn't link it.
Okay, so that one is that on archive, or is it on like a different journal?
Archive.
Yeah, if it's on archive, then it's free, right? So you should probably link it there for sure. I would actually put that as like the opening point, like not like put it like near like the subheader or something. Like put a link to like archive, like put like publication, and then put like a link icon or something. That would definitely be
Yeah.
pretty eye catching, I think. So that's good.
Right.
And what is this? Undergrad research assistant, blah blah. Okay, okay. I mean that's like whatever. That's chill.
Yeah.
Project. You have a YouTube. That's good. Voice control image editing web app. Okay, that's pretty cool. And the YouTube is a demo.
Yeah.
Okay, this is good. That's good. And then what is this? Is this reinforcement learning? GPT-2.
Yeah.
Okay.
This is what I
Implemented
work
this
on.
thing. GitHub. Intending to find it. Is this a paper or is this just a concept? I'm not too familiar with this. Implemented RL
So
fine tunes.
this is an implementation of a paper, like a famous paper. Yeah.
Okay, got you. Okay, I'm not really in the field, so I can't really tell if something's famous or not.
Yeah.
Okay, I see. Read into the paper of this thing. Okay. Present to someone trying to play. Okay. And repository. Does the repository have like a nice README on this one?
Yeah.
Okay, that's good. I think these two probably are actually very strong. I think they're actually quite good. Languages wise, I mean, like I'm not gonna sit here and tell you what's going on. What do I expect? I expected SciPy. I guess it's like whatever. I expected Matplotlib. That's like whatever. I have not heard of 1DB, OpenCV. Everything else makes sense. Transformers. Is this a
Yeah,
library?
it's a library for
Oh,
like language models.
okay. Any TensorFlow? Any PyTorch? Oh, you have PyTorch.
PyTorch is
Okay, I see.
yeah.
Okay, okay, that's not bad. Get Docker unit. Okay. No, I think this is not bad. I think this has a lot more actual research, this resume, than a lot of other ML things I see. So I think there's actually a pretty solid back over here. Do you have anything specific you want to comment on? Because I think feedback wise, I don't really have much to say. Like I'm not close enough to that field to really give you anything actionable here. It's just a couple things for me, like a general resume kind of aspect is things like publications and papers really help you stand out in this kind of regard. So if you have anything over there to kind of help it stand out, that's like really good. And otherwise, I think there's a couple of things here that I saw were pretty fun. I think the first thing was Putnam. I think any Putnam recognition is really cool, obviously. I mean, especially going to ML math kind of area. And then of course you have the one paper that's submitted. You have the other one you're working on right now. I think get those on there ASAP, and then I think it's good.
Yeah, sounds good. Yeah. Yeah,
All
I
right.
was gonna ask, like, should I include the papers? Because it doesn't, I don't know, but yeah, I will now.
I definitely think you should because they don't need to take up that much space. It could even be a simple half liner, put in the header, etc. I think that could be good. In most of the time, I would even say like most people should be making room for papers. So if I were you and I were like the streamline this resume, where I would consider like making room is I would consider not like removing a point from the math department undergrad research assistant, but 4 lines over there is a lot of lines, and I don't think you really need all 4 lines there. So I could say, hey, you can maybe remove a line there, cut down to 3, cut down to 2 lines, right? Summarize both of that, because over here I don't see anything that's too insane to be honest with you. So
Yeah.
you don't need that much detail there. That could save you a line or two there, and then I think maybe your second project you could probably save a line from the second point by refocusing that line to be mostly about how you did the analysis, how you presented it, etc., and move the paper archive, like the archive reference, to the sub or to the subheader. I think that could be okay.
Right.
Although to be honest with you, like if most people in the field know about this paper, then you probably don't need to mention it. I just don't know the paper, right? But many people might,
Yeah.
so probably save a line there. Overall, no, I think this is pretty strong. I think you got a good. I think you got something good here.
Right. Yeah. Sounds good.
All right. Anything else?
Okay. Yeah, that's all. I'll leave the call now. Thank you so much for taking the time to interview me.
You're welcome. Take care. All right. Now guys out of here. Got one more submission. Let's take a look. All right. Let's take a look. So. All right. Looking for software engineering new grad roles. Already have good RO, but looking for something better. Specifically, want to go into infrastructure, platform, cloud. Want to break into Databricks, Netflix, Pinterest, Centric, Google. Those specific 5 companies. I've never seen that. Never seen those 5 called out explicitly, but that's cool. Let's take a look. Well, Databricks is up. Wait, where are you? Okay. Well, Databricks is opening up in Vancouver, so come to Vancouver. All right. To present. Provide new notification experience to service and instant knowledge. New notifications experience to surface. Okay, I don't know what this thing is, but okay. 100+ enterprise customers. Ship Bug fixes, UI improvements. This is a bad point. This isn't really. You've been here for 3 months already, right? You should have better points than this one. Talk more about the first one. Prototype. I mean, prototype is, I guess that's the best word you can put if you didn't really ship it yet, right? But if you spent 3 months prototyping that, then I would definitely say put some more information here. Otherwise, if they just unfortunately slapped you on the bug fix job for as an intern, then do what you can here. At this point, I mean, it is your most recent experience, but it's not like this is right behind it. So if this is much better, we can look at removing this point. Okay, Confluent's pretty good. Let's take a look. Build a self-serve infra, Golang React. Enable teams to onboard a use case while entering supports. Automated resource tracking dashboards and implement our week. Resource tracking, real-time metadata, Kubernetes, custom resources, blah blah. Okay. With internal MCP, expose data in chat. Okay, 3 months. Okay, what did you do? Golang React. Automated this. How did you do that? Unsure how you did this one. Kubernetes. Integrated with the internal. Integrated what with the internal what? Integrated this. These points don't really make sense. You gotta rework that, I think. Okay, super.com. Kind of done the end at 8%. Okay. 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 I mean, talk about it. What did you build? Running from asynchronous event driven processing. Unlocking real-time okay, catalog. These 2 points could probably be done together, if I understand this correctly. Fast API-based REST. Allowing efficient. Okay, so if you built the front end, this point you can clarify. If you didn't build the front end, get rid of this point. KGG. Okay, 2 Google API stuff. Cut cost. Okay, this is about a year ago. Okay. Looks at it. So you would need to clarify what these 2 are, because it's unclear how this it's unclear how this worked. Instead of CI and test 2 seconds, sure. Also missing the how, but sure. Optimize the core web vitals performance in Next.js, leading to improved search engine rankings. You can probably quantify this, yeah, but that's fine. Introduce 10 plus features to improve accessibility. Okay. That makes sense, but if you're going for infra, at this point, it doesn't make sense, right? It doesn't matter. Okay, RBC. Okay, so this point is good. This point has an impact. It has a how. This is a good point. I can believe that. A full stack as a cloud platform achieving. Okay, this is a good point. I would, instead of framing this as achieving a % uptime, as an improving the uptime. Because 99% uptime is pretty bad. Okay, these are a long time ago. Okay, let's take a look. This should be 1 point max. Hold on. Okay. Location-based matching for skill. Okay. Okay, this. If you like these projects a lot, you can keep them. If not, I will put them 1 point max each. That's fine. Okay. Yeah. Okay. So, first of all, which break into. Okay, you have an RO. So if you have an RO, take the RO. Get good at your job as a full-time, and then jump. Much easier. Resume, you have a lot of good stuff here. but the framing doesn't make sense, not coherent, and you could really tailor this if you're especially going into infra platforms, etc. Cloud stuff. Here's the thing about cloud stuff. I saw a lot of cloud here. It's unclear a lot of the motivation behind the points. Um, I think this applies to all of them, but especially the cloud ones. Like this one, for example, could just be a misframing. I'm not really sure what the framing here exactly was, but 99% uptime is less than the uptime of. Wait, did you say which cloud you're using? No, but whatever cloud form you're using, I'm sure they have a better than 99% uptime. So if you're only getting 99 out of, let's say let's say they have 99.99, that means you have 100 times worse uptime than the cloud platform, right? So it's like, hey, the work here is probably very good, right? But the framing here is off. So I would definitely say look into how you can improve that, see what's going on there. Now again, if these are like internal apps where the uptime doesn't matter, then it's like, okay, who cares? But then in that case, I wouldn't frame this work as like improving reliability, right? So maybe a better framing there is lacking, but I think the work is fine. I think the work makes sense. All right, let's take a look. Oh. No, that's all the resume submissions. So I'll wait like 3 minutes, and if there are no more resumes, then I will end the stream here. Do I have one? Yeah, there you go. Alrighty. Did anyone submit their resume? The answer is no. That's all. Okay. In that case, we're done. Get out of here.